number is 72. I also request team number 73, Victoria Technologies, team 74, Ashok Leyland, team 75, Wipro Infrastructure to be ready with your presentations.
So a very good morning everybody. Our Kaizen theme is optimization of the steam load in the East Gyre. And I am Bhashini Sarkar, along with me Adarsh will take you through our Kaizen journey. About our company, we are now under the umbrella of Heineken International and we are producing Kingfisher Strong along with a Heineken brand like Amstel. So our Kaizen is very much aligned with our UB Odisha strategy and which is very much aligned with our Heineken and Indiaco strategy, where we are focusing on the raise the sustainability and the responsibility bar. Now we have done a loss deployment. There we have seen that there is an excessive expense of 4.73 million only in spent handling than the budget expense during our Q2 2024 cost loss deployment. To counter that, we have taken the project of UPS methodology to attack it. So we have formed a cross-functional team. Now let us understand how this surplus yeast is being generated. So in brewing, yeast is added to the wort to convert it into the beer, post which this is being disposed. So we left with two options. One is either we can dry the slurry yeast and sell it as animal feed, that is a revenue source for us. And the option two is we can dispose it on a payment basis as this is a biohazard and through a pollution control board, and it is occurring a huge expense to us annually. Now let us understand how the yeast dryer is working.
Since yeast dryer is a part of this project, let me explain the working of an yeast dryer. Initially, the slurry yeast is being pressed in a hydraulic press to remove any excessive moisture, post which these cakes are being fed into the yeast dryer. In the yeast dryer, the ambient air is heated using steam and passed in the wet yeast. Instantly, the wet yeast is dried until the moisture content becomes less than 10%, post which it's taken out and sold to the market.
So let us understand the problem from its root. When my market demand has increased in the year 2022-2024 approximately 26%, and this gives a huge rise in the volume. Now when my volume rise up, so my yeast generation also increased by 7,769 kg per day. But I have only one yeast dryer. With that maximum I can utilize 3,000 kg per day. But remaining 4,769 kg I am unable to utilize. For that I have to discard it outside. So one dryer is just not sufficient, but fortunately we just had purchased a new yeast dryer as a replacement for the existing dryer. But to save the cost, instead of replacement, we decided to parallelly run two yeast dryer without any capex investment. So addressing this, we came up with three major challenges. The first challenge is processing capacity limitation, where we are getting the yeast dryer, not the pressing unit. So we have to see the feasibility, whether my current dryer is feasible of running the second yeast dryer. Second challenge was the insufficient steam. We are currently running at 6 TPH, which is our peak boiler load. And the third challenge was the space limitation. My current boiler is designed, current space is designed for the one yeast dryer, not for two dryer. So we have checked the feasibility by doing the time study, where we have seen that our yeast placing is taking 50 minutes and the drying is taking 10 minutes. So there is a more than 50 minutes time between two subsequent batches, and this time I can effectively use for my second dryer. So this gives a huge thumbs up for this.
Since the problem of the yeast press is solved, we move to the second problem, insufficient steam supply. Stratify the problem using 5W1H methodology.
So what is the problem?
Parallel operation of two yeast dryers.
Who is affected by this problem?
Boiler and the nearby people.
Where is the problem
This is
exactly?
boiler 6 TPH.
When is the problem?
Operation of both yeast dryers during the peak load of the plant.
Which type of problem it is?
Boiler drum load will become low, leading to boiler implosion.
How the problem occurs?
Demand load will be greater than the boiler output threshold. So to counter this, first we took the process of RBC to ensure that we maintain the standard to save any excessive steam which is being used and run the second yeast dryer. First we clean the condenser coil to make heat exchange efficient. Second, we are insulated the existing yeast dryer to prevent any radiation loss. Third, the incoming air filter was modified in regular cleaning. Fourth, the PRV was installed in the steam line to maintain a constant steam pressure. Although we have done the RBC, over the course we have found 20 abnormalities and 20 abnormalities are solved. We restrict the standard parameters still. Although we save some steam, it does not open room to a second yeast dryer. So we took the root cause study using a verification sheet analysis. From the verification sheet analysis, we have analyzed the steam load consumption for a day during a peak load, that is May 16, 2024. From the sheet, we found two analyses. First, the load of 60 pH was not a constant demand, constant load, it was spike demand. Second, these spikes were not sporadic, it was sporadic in nature, meaning there is an average time of 3 hours. So upon further analysis, we found that these spikes happen when there is some overlapping of mashing and boiling cycle. So we found if we could manage these spikes and somehow utilize the area 3 hours gap, we can efficiently use the second Easter egg. So we took this to a brainstorming session. We came up with 2 options. Option 1, reduce the peak load by operating the Easter egg. That is, we change the boiling and the mashing cycle so that this peak does not occur. But this was a strict law because this meant the changing of the process methodology. It's a quality deviation. We took the option 2, operate Easter egg when the demand is low. That is, in case since Easter egg being a non-critical load, we can cut off the Easter egg when the demand goes more than 60 pH. And this does not impact the quality of the yeast. Also, we derived this idea from the electrical grid, that is demand side management. When the power is low on the grid, we isolate all non-critical load to ensure smooth flow of power. So we took this option 2. So to effectively implement this option 2, we made a small automation. That is, we interlocked the main storm flow meter with the control valve of the Easter egg. Once the load goes beyond 5.8 kPa, the steam control valve of the Easter egg is shut. Then the steam is not supplied, thus ensuring there is no water carryover in the boiler line and the boiler shrinkage does not occur. And to indicate to the operator this event has occurred, there is a hooter to indicate the operators. So upon implementing this, to sustain this policy, we have included the daily checklist to ensure the automation is working or not, and we have added a simulate button to daily check it. And we have given training to the operator to ensure the same. To check whether the follow-up, the automation has worked or not, we have taken another peak date, that is 29th of June 2025. Here you can clearly see by executing this, I got 2 benefits. First, I was able to operate 2 Easter egg, and second, no more spikes were being created because I efficiently cut off the non-essential load. Because of this, I got an additional benefit of there's no more spikes in the boiler output, and there's an optimal consumption of steam. And to counter the third issue, that is a space constraint, we took the ECRS approach. In the ECRS, we first eliminated all the unwanted vents in the steam line, and we combined. In the combination, we combined the 2 Easter egg platform for an efficient operation, and we combined the condensate SOP for both Easter egg with a single line, and we rearranged. In the rearrangement, we positioned the post Easter egg parallelly for easy operation and maintenance, and we rearranged the blower position due to space limitation, and we rearranged the entrance for an efficient operation. And in the simplification, we used a common steam header for both the Easter egg, and we simplified the condensate header for better accessibility and maintenance. So upon implementation of this, that is post August 29, we are able to achieve 9 batches. That is from 6 batches, 9 batches. We additionally got 3 batches extra.
So by implementing this, not only we have saved the cost, but also have generated some revenue. So we have saved the cost in 2 forms. First, we have saved the cost by utilization of the 2 dryer and not disposing of the yeast. In that, total cost we have saved 10.1 million. And additional revenue we have generated by selling this dyes, that is 4.3 million. So total overall 14.4 million cost we have saved by year.
Learning. Since we challenged the design capacity and succeeded, we are exploring furthermore possibility to produce more batches. Furthermore, to enhance the boiler safety, we are installing a single element to maintain the drum level at 60% at all time. And to further reduce the peaks of the boiler, we are installing a steam accumulator in future. Over the course of this project, we got experience using tools such as UPS and RCFA. The Kaiser was shared Heineken global team to also be deployed to the applicable brewery. Thank you.